Hello and welcome to the Barcast. I'm your host, Nick Barr, coming to you on a Tuesday evening. If you're familiar with the Barcast, you'll know that this is our first video Barcast. Usually we're on the podcast and you can subscribe on iTunes, Stitcher, or SoundCloud. But we had to switch mediums for this Barcast because I've got a lot of stuff I want to show you. And the stuff that I want to show you is sort of under the umbrella of what I would call rule-finding games. So what do we mean by rule-finding games? Well, start with this. Most games, I would say, are rule-following games, not rule-finding games. That is to say, when you play the games, you learn and then you follow the rules. So, for instance, in chess, you might learn how a pawn moves. It goes forward one square when it's moving, but then it attacks diagonally onto the same color square and so on. Or if you're learning how to do a crossword puzzle, you might know that in the acrostic, at least, you're trying to spell out the words from a passage, like so. And the clues themselves will have answers that spell out in each of their first letters the writer of that passage. So imagine this is Virginia Woolf writing something that has the phrase "of owl" in it, and that's how an acrostic is solved. Or just a game like soccer, don't use your hands. Offsides, etc. And so these are rule following games, and most games are rule following games. But I wanted to discuss in this Barcast a special category of games that I call rule finding games. And in these games, you don't know what the rule is, and in fact, the substance of the game, for the most part, is to actually just find out what the rule is. And I think we can illustrate this with some examples. So, the sort of grandfather of this genre that I just created of rule finding games is called the Bongard problem. And you may or may not find the Bongard problem interesting. I find it super interesting, but if this bores you, just hang tight. Maybe something later in the Barcast will be of interest to you. Bongard problems were created in, I think, the 60s by a Russian physicist or computer scientist who designed them to essentially test computers. It's a little bit like the Turing test, which is a test for a computer to see if it can fool a human into thinking it's a human. A Bongard problem is a test to see if a computer can perceive the world at the same level a human can. And so the structure of a Bongard problem is pretty straightforward. We have some shapes on the left side here, and we have some shapes on the right side. Let's call left side A and right side B. And the goal of any given Bongard problem is to find the rule that causes the shapes in A to be in A and the shapes in B to be in B. So we'll make this an interactive Barcast, and so if you want to work this one out, go ahead and pause now. And you probably figured it out pretty easily. The shapes in A are all straight edges with corners, right? and the shapes in B all are curvy with no corners. Right, and so that's the rule that separates those two. So for instance, for any given shape, we would know whether to put it in A or B. That's a pretty straightforward Bongard. Oh no. But let's do a couple more. So again, this is side A, this is side B. What is the rule by which the shapes in A go in A and the shapes in B go in B? Cool, that was your pause to figure it out. I like this one because I find it really intuitive, but it takes a second. You can see a difference, but it takes a little bit longer to know how to articulate the rule. It's just simply that if you work your way up from the bottom of the branch, the shapes on the left all go left, whereas the shapes on the right all go right first. So these are Bongard problems, and you can find them online. There sort of are some classic ones created by Bongard himself, and then another few hundred created by fans. One of those fans is Douglas Hofstadter of Gödel, Escher, Bach, and I think this is one of his. This is a tricky one, so I'll give you a second now to pause if you want to try to solve it. And this puzzle is starting to get at how Bongard problems become very interesting and very difficult, because here you have dots, and there's any number of ways you might start to try to figure out what the dots signify, right? I mean, what is the purpose of these dots? If you're like me, you immediately started drawing triangles in your mind. I think it's hard not to, because there's 3 dots in each case. But the triangles don't really get you too far, I don't think. And so what are you left to do with these dots, right? You might start to segment them up into quadrants and sort of say like, oh, okay, well, 3 are here, but now 2 are there, et cetera, et cetera. And so you start to like bump against these limits that are really interesting, which is essentially the limits of the universe about how these dots might be applied. This one is funny because to solve it, you need to sort of reduce your perception. You need to see less, and all you need to see is the distance between dots. And once you start looking at that, you'll see that in A, the dots are all equidistant on the x-axis. I think I have that right. And then on B, the dots are all equidistant on the y-axis. And so that's the rule by which these are separated. And then we'll just do one last one that's also kind of fun. Oops. Give you a second to solve this one. And I like this one because this is one that, again, I found to be an instant solve, but you can imagine a computer spending endless cycles trying to figure it, because it requires a little bit of cultural knowledge or world knowledge. Specifically, all the lines on B are valid times on a clock, whereas all the lines on A are not. They don't work as times. And so of course you would need to be able to tell time. You need to have seen a clock to know this rule, and it starts to again point at the scope of Bongard problems as sort of constituting all of human knowledge. That's what makes them a good puzzle for computers. So that's Bongard problems, and those are one kind of rule finding game. I find them interesting, but they're a little bit. I guess you could say they're a little bit over constructed. They're a little bit kind of academic. They're sort of like taking your computer to the optometrist and asking it to choose between A or B. One of the things about the Bongard puzzles that I find limiting as an example of a rule finding game is as soon as you find the rule, the game is over. There's really nothing to do. And so to that end, these Bongard problems themselves are constructed in such a way to make it super obvious when you've got the rule. Because when you figure out the rule, you're done. You're not going to get any right, wrong feedback. You're not going to start applying the rule. And that's not really the case for all rule finding games. So let's leave our Bongard problems behind and talk about a really simple exercise, and yet a really powerful one that I find really fun and interesting. I call these card sorts, but you might have another name for them. And I've seen them in disciplines as far-ranging as user research, where you might ask someone to organize cards a certain way or sort them a certain way, as well as education. And I think education is my inspiration here. The app Desmos has some fun card sorting activities, so you might want to check that out. But this is a very simple example. And so let's say I'm a teacher in the classroom, and I've got these cards arranged on the table, and I simply ask students, come up with a rule to organize them, and then challenge your classmates to figure out what that rule is. Right? And so one student might put some cards on the right side and put some cards on the left side, and we might pretty quickly be able to tell that the rule is that A is odd and B is even. And some other student might be a little bit trickier and do something like this. Right? And we say, well, this student knows primes, so A are prime numbers and B are not prime. And then still another student might do something completely different and organize the cards this way. And if I were conducting this as an activity, I might let student A come up to the board to do his sort, and then ask student B, or even have student A ask student B, okay, well, for the number 14, where should it go, B or A? And the student has to figure out, well, what's the rule that I'm going to apply that puts 14 in one category or the other? And they might put it in A, but they might be wrong because the rule was actually the ages of students in our class. And our class ranges from 9 to 13, but we don't have any 14-year-olds in our class. And so, again, this is sort of bumping against the limits of mathematics versus the limits of culture. This is sort of any sound rule applies here, and it's sort of up to the person what a good rule is, right? I mean, this person could easily just to say, I'm thinking of the numbers 2, 3, and 6, and I'm not thinking of the numbers 9, 13, and 12, but that wouldn't make for a very fun rule. So card sorts are another kind of rule-finding game, but unlike Bongard problems, which are sort of like laboratory experiments, card sorts are a little bit more flexible and invite follow-on application, remixing, conversation, argument. So that's one kind of rule-finding game, the card sort. I want to switch gears completely and actually jump over to Twitter to see another kind of rule finding game that I think is exciting. So on Twitter, there is a word game account called Puzzler, PZLR, or the Mystery League. It's pretty neat. Started by Sandy, who has a bunch of really cool projects, so I recommend checking them out. And the Mystery League has been going on for a while now with some really great brain teasers that I would also classify as rule-finding games. And let's take a look at them here. So this one, these phrases all share a certain quality. Respond with another phrase that can join this set. And you can see the phrases in the set. And I'll give you a second to try to solve this one. Although if you're like me, you'll need a couple hours. Okay, whether you solved it or not, I want to call your attention not so much to the problem itself, but to the way that the problem is solved collaboratively online as Twitter users try to find the rule together. So in the replies, Twitter users are solving the problem, right? I think that's what's really interesting about this particular approach is the way you solve the problem is by applying the rule. And the way you apply the rule is in public, such that everyone else who is trying to solve the problem benefits from your solution in their attempt. Right? So I might not get it from these first 5, but these are crafted somewhat carefully by the puzzler creator. Other people are just throwing in their solutions. So for instance, colors that make your book, well, this is strange. He's capitalized K here. So that might give you a hint. Just popular groovy rockers. And here's yours truly participating with my solution. We shepherd navigation elegantly. And somewhat charmingly, another solver replied to me. And so there's a lot to tease apart here. So let's get into what the actual solution is. If you didn't get it already, and I think this is a really devious one, the quality or the rule I would say that these phrases share is that the capitalized letter in each word is also the first letter of something that these phrases are describing. So bustling boroughs of quite sprawling metropolis are Bronx, Brooklyn, Queens, Staten Island, Manhattan. Handsome little ducks are Huey, Louie, and Dewey? Loony comedic men are Mo, Curly, Larry, and so on. And so if we go back to my response, again, my response is my proof that I understand the rule, and my proof that I understand the rule is my ability to apply the rule. I said, we shepherd navigation elegantly. And that's the cardinal directions, west, south, north, east. But Doug took the same 4 letters to solve to apply the rule in a different way. Now with the smaller empire would be Great Britain, which consists of Northern Ireland, Wales, Scotland, England. So I find this to be really exciting as far as rule-finding games go. It's a little bit like improv, right? There's a way to participate that itself is an invitation to others, and your participation can help other people solve the problem. It can give solvers little sort of side channels to play in, and it's really, really fertile. I'll just show one other Mystery League puzzle because I think it's worth calling out that one of the classic subgenres of rule finding games, right? You can either have rules that describe a set like this one, or rules that describe a sequence like this one. So let's take a look at this. These words make a sequence. Post a word that comes next, or post one that can follow someone else's response. Corn, hind, scape, fence, lope. I'll give you a moment to solve this one. Okay, and if you have solved it, good for you. Brian kind of gets this firsties benefit, right? So this is another kind of quirk of Twitter. I don't know if you... This is a meme that completely like fell out of fashion, but there was a time that people would just comment first if they were the first to comment on anything. Like a news article would come out, and the first commenter would just say first. I guess that was a property of the era in which there were no sort of sorts by popularity or usefulness. And so there was real cachet to be associated with being first. Actually, now that I'm describing this, I think Twitter still works this way to a large extent, which is like if a celebrity tweets, I think people rush to be first because I do think that maybe their reply gets seen early in the same way this has happened here. But unlike celebrity Twitter, this is actually happening to good effect. So Brian is adding to the original set, or sequence rather, and then James is building on Brian's. Twitter's threading, I think, does hold up here. And so without knowing exactly what's going on here, let's just solve the problem. Corn starts with A, acorn, behind, seascape, defense, elope. Brian is stretching us a little bit with effluent, and then James has genotype, and so on. So that's a rule finding game that obeys a sequence, and that has its own interesting properties that I think are served really well on Twitter because it creates a little bit of urgency. There's a little bit of cachet to be first. But at the same time, the set rule finding game works really well too. So I've been playing a bunch of these rule finding games, and I have to admit that I've been inspired, and so I've created my own rule finding game, and it's called Bongo, and so I want to show that to you now. So the object of Bongo is to advance through life without dying. There's not much lore to this game, but the lore is that you start out as an egg. Players take turns filling out the squares, and they advance through life trying to end the game before someone fills the last square, because everybody loses if the last square is filled. So when it's your turn, you fill the square with some object according to a rule that you have in your head. And so, like, let's say I'm the first player, so I'm going to put the number 3. Because I'm thinking about a rule in which each number goes up by 1. So I expect the next person, if they follow my secret rule, to do number 4. But now it's player 2's turn, and they're going to come up with their own valid rule to continue the sequence. So maybe player 2 instead is going to do, let's say, 5. because in their head, the rule is we go up 2 with every number. But then player 3 has another idea. It's the previous number times 2 minus 1. 3 times 2 is 6, minus 1 is 5. 5 times 2 is 10, minus 1 is 9. And now it's back to player 1. And player 1 originally had this rule in their head, right? You just add 1 every time, but that rule is obviously no longer in play. And so they're going to have to come up with some sequence or some continuation of the sequence according to a rule. Now, let's say at this point, player 1 is really like not sure what's going on. And so they're just going to fudge it and say, well, okay, 3, 5, 9, 13. The next player who's up, in this case player 2, they might be really confused at this point. Oh, I don't see the rule anymore. And so they can challenge player 1. And if they challenge player 1, they say, what was the rule? And if player 1 can answer the rule, then player 2 loses a heart. But if player 1 says, you caught me, I was fibbing, then player 1 loses a heart. So that's the gist of the game. So the game is all about basically kind of pretending, faking it until you make it, right? It's playing the game according to the rule that you think is going on, or making a new rule, or faking the rule altogether. And there's a little bit of pressure in this game because, like I said, if the rule is trivially easy, then we'll all just make it to the end of the life and we'll all lose a heart. And so it's not enough to simply follow the rule. You have to make the rule obscure, like the rule can't be surface level obvious. And so from limited playtesting, I find that creates a pretty interesting vibe for the game. And I'll share an early playtest now to give you a sense of that. So here's 3 of my colleagues playing an early whiteboard alpha version of Bongo.
I don't know. That doesn't seem right, but I'm not going to call you out on it right now because I don't want to die.
Order matters.
Order matters.
Prevailing paradigm. What?
I think it's this. Is it this?
Oh my god. This rule is ridiculous.
But eventually, the game comes to a halt as Kit accuses Elizabeth of winging it. So let's take a look at that conversation and debate.
Lord. Alright, I don't know what that's going on. Explain yourself.
So what I've been doing is taking at least one element from the square before and incorporating in the next square. So
okay.
This one has like 5 petals, this has 5 fingers, and then this part of the flag I just put in the middle of the sun. For this one, you took one of the dots in the middle and made it an eye.
And the circle is that?
Yeah,
something?
yeah. And then this is kind of like like you're saying hi. And then you took the 2 dots here and over here.
But what about this and this?
Those are related because
Did You mean
Like
elements?
you're like waving high. That one's the I don't know if that counts.
Okay, so
That threw me off.
what's the verdict? What were y'all thinking?
I think your story breaks down here because I don't think there's like a visual element really from one to the
Yeah,
next
before
so
you were
much.
saying visual elements, the high and the hands are not as visual.
Maybe they're the same. Like the stroke length is the same if you combine like the lines together.
Here's a story I was gonna tell. These are ways of greeting a person that are growing in terms of like magnitude. So you might just smile at someone, you might say hi, you might wave, you might give them flowers, you might bow to them, you might raise their flag. And I was like, I don't know what this is. My story started breaking down. I'm like, all right, I don't know what's going on.
You know, for me, I was actually going in a very different direction. I was thinking this is the story in order of someone's trip to Japan, where they're happy, they say hi to someone, then they see the chrysanthemum that people are bowing down to, and then they see the Japanese flag, and then you could have continued the story.
The next day they wake up.
Yeah. It's still order. Order matters.
So I think the jury is still out whether Bongo is actually a fun game to play. I don't have enough data yet, and in that spirit, I will attach the game template to the show notes so that you can download it and play it at home. Let me know how it goes. So I don't know if Bongo is fun, but I will say that like as I watched my friends play it, I did feel like something kind of human was going on. And even as I say that, I don't exactly know what I mean by it. Playing Bongo was watching people sort of play life in a way. We were working out muscles related to living and interacting with the world that we don't necessarily normally interact with. And so I think that's something special about rule finding games. I mean, it's explicitly true and obvious in Bongard problems, right? Where the whole purpose is to test out our perception explicitly. It's all about our ability to recognize rules by seeing in many ways. But as soon as you validate that perception, the game is over. Puzzler, the Twitter game that I shared, takes it a step further, because when you know the rule, you participate. So you add to the game rules. Same thing with the card sorts. So you're testing out not just your ability to find the rules, but to reapply them and create new ones. But with Bongo, we just take it one step further. We're working out our ability to change rules, to conceal rules, to make rules themselves the materials of our game. And all this makes us a little bit more dexterous at navigating the world, at living, because life is sort of a set of uncountable, secret, hidden rules. And I just want to close with the work. I just want to close with a passage from Impro. So if you do improv, probably this whole barcast has been a little bit duh to you, because my understanding of improv is that the whole thing is participating in these kinds of games. I don't do improv, but I did read the cult classic Impro, Improvisation in the Theater by Keith Johnstone, and it's a really striking, unique book. Highly recommend it. And I'll just read the first pages of the book here, in which Johnstone describes making a discovery that changes the way he approaches improv forever. So this is chapter 1, Status. When I began teaching at the Royal Court Theatre Studio in 1963, I noticed that the actors couldn't reproduce ordinary conversation. They said, Talkie scenes are dull, but the conversations they acted out were nothing like those I overheard in life. For some weeks, I experimented with scenes in which two strangers met and interacted, and I tried saying, "No jokes," and "Don't try to be clever," but the work remained unconvincing. They had no way to mark time and allow situations to develop. They were forever striving to latch on to interesting ideas. If casual conversations really were motiveless and operated by chance, why was it impossible to reproduce them at the studio? I was preoccupied with this problem when I saw the Moscow Arts reproduction of The Cherry Orchard. Everyone on stage seemed to have chosen the strongest possible motives for each action. No doubt the production had been improved in the decades since Stanislavski directed it. The effect was theatrical, but not like life as I knew it. I asked myself for the first time, what were the weakest possible motives, the motives that the characters I was watching might really have had? When I returned to the studio, I set the first of my status exercises. Try to get your status just a little above or below your partner's, I said, and I insisted that the gap should be minimal. The actors seemed to know exactly what I meant, and the work was transformed. The scenes became authentic, and actors seemed marvelously observant. Suddenly, we understood that every inflection in movement implies a status, and that no action is due to chance or really motiveless. It was hysterically funny, but at the same time, very alarming. All our secret maneuverings were exposed. If someone asked a question, we didn't bother to answer it. We concentrated on why it had been asked. No one could make an innocuous remark without everyone instantly grasping what lay behind it. Normally, we are forbidden to see status transactions except when there's a conflict. In reality, status transactions continue all the time. In the park, we'll notice the ducks squabbling, but not how carefully they keep their distances when they are not. So that's Keith Johnston's Impro. It's a really great book, and he goes on to share a bunch of other exercises as well as conversations that ensue from it. So go off and play some rule-finding games. Go off and expose some secret maneuverings. And participate in the forbidden act of seeing the systems and rules and games that we're all playing all the time, even if and especially if we don't realize it. See you next time.